in today's lecture, I am going to explain Newton's second law of motion. So first law of motion, you can just see the previous video. You will understand what is first law of motion, and now it is second law of motion. Now, take an example as I have taken in the first law of motion also. It is a table and there is a duster on the table which is in state of rest position, right? The duster is in rest position. Now, if we want the duster to move, okay, what I need to do if we want the duster to move? So what will happen? I will apply a force on it. And the duster will start moving in rightwards direction. That means if I am applying a force on a duster, that means it is changing its state from rest to motion, right? It's changing its state from rest to motion if we apply force. And now if I'm applying force, it is changing its state, and changing its state means its velocity changes. It develops its velocity. Like initially it was at zero velocity. There was no velocity. Initial velocity is zero and the final velocity is something, right? So it is changing its velocity. And we all know that if there is a change in velocity, that means change in velocity with respect to time. What is that? We have studied earlier also, it is an acceleration. That means I can say that if I am applying force, that means there is a change in velocity, right? And change in velocity means it is producing an acceleration, right? You understand this? So this thing you need to remember. We will write the statement of the Newton's second law of motion after I will explain everything, right? That means I am applying force, there is a change in velocity and it is producing acceleration. Now, I need to explain the acceleration, right? Obviously, remember, if it is a ball and I am applying force in this direction, so acceleration will also be in this direction, right? If there is a ball, I am applying a force in this direction, then obviously the acceleration will be in this direction, right? If it is a ball and I am applying a force in this direction, so the acceleration will be in this direction, right? Now, on what factors this acceleration depends? Factors on which acceleration depends, right? I'll explain this now. Suppose there is a ball of 10 kg and there is another ball of 10 kg, right? Now I am applying a force of 20 newtons here and applying a force of 50 newtons here, right? There are two conditions, right? Now tell me what will happen, where the acceleration will be more. Obviously the ball are of same mass, 10 kg and 10 kg, but the force is different. That means this is a lesser force and this is the higher force, more force. So where the acceleration will be more? Obviously acceleration is directly proportional to force. That means if force is more, then acceleration will always be more, and if force is less, then acceleration will be less. As you can see that it's a 20 Newton force and the ball is 10 kg. So the ball will move in the rightwards direction, right? But there will be less velocity of the force. But now it is 50 newtons. So ball again move in the rightwards direction but in a more velocity. So if force is more, acceleration will be more. If force is less, and acceleration will be less. So this is the first factor. Let us say this is equation number 1, right? Now the another case. There is a ball. Again, the ball is, this ball is, suppose what I said, yeah, 10 kg. Suppose this ball is 10 kg, and now there is a ball of 20 kg here, right? But now the force I am applying is 10 newtons, and here also the force I am applying is 10 newtons. I am applying the same force on, but now here the mass is different. It is 10 kg, it is 20 kg. What do you say now? The ball which is of less mass, right? It will move more, and the ball with the more mass will move less on the same force, right? Suppose, you can just take an example. Suppose a man who is 50 kg, a man who is 100 kg, and I'm applying the same force. So what will happen, right? So basically I can say that acceleration is inversely proportional to mass. And I can say it is equation number 2, right? That means what I'm saying now, if my mass is more, then the acceleration will be less, and if my mass is less, then the acceleration will be more, right? So I got these two equations, the first and the second equation. Now combining equation 1 and 2. I need to combine these two equations. So what will happen? So the first equation is acceleration is directly proportional to force, and second equation is this one. So by combining these two equations, can I write acceleration is directly proportional to F by m, right? That means if I am removing this proportional sign, that means there will be a constant here. Suppose the constant is k, and the value of k is 1. That means I can deduce A equals to F by m. Or can I write F equals to mass into acceleration, which is the most important relationship between the force, mass and acceleration. And this is our Newton's second law of motion. Right? Now, I need to write the statement of Newton's second law of motion. So, for writing the statement, I'm taking this pen, statement of Newton's second law of motion. So I explained everything. I'm writing the statement now. Whenever a force is applied on a body, it produces acceleration, right? This is the first part. It produces acceleration in the direction of the applied force. In the direction of the applied force. So there is no need to just cram this statement. Just understand. So the first part, what I explained, yes, the first part I explained, if I am applying a force on the duster, it is producing acceleration. So I have written, whenever a force is applied on a body, it produces acceleration in the direction of force. So whatever will be the direction of force, the direction of acceleration will be the same, right? So this is the first part of the equation. Now, the acceleration, so I can say it depends on two factors. I explained it is the force and the mass. So I can say acceleration whose magnitude is directly proportional to the applied force, right? And inversely proportional to mass, as I explained above. Right? So proportional to the applied force and inversely proportional to the mass. So if you need to write the statement of the Newton's second law of motion, you will write this equation. Okay, you are going to write this equation plus this all thing. The acceleration is directly proportional to force, it is inversely proportional to mass. You need to combine these two equations and you need to write F equals to ma. So this is the mathematical analysis of the Newton's second law of motion. This is the statement of Newton's second law of motion. And now thus the SI unit of Newton's unit of force. So you all know it is Newton, but I can say SI unit of force. Basically, force will be equal to, see, M into A. So mass, force equals to ma. So mass we measure in kilogram and acceleration in meter per second square. So I can say F equals to kg meter per second square, or I can say Newton or N. So Newton equals to kg meter per second square. So this is the SI unit of force. So this is all about the Newton's second law of motion. I hope it is clear to you.